Humanity has come to develop the ability to understand and manipulate the complexity of the structures that surround us. Water is two hydrogens and one oxygen. The lights can be broken down into circuits, and buildings such as ECS West can be broken down as structures. This brings us to finite element analysis, which can be used to test structures such as ECS West. Why are people able to trust the stability of buildings? How are engineers able to know when a structure is successfully designed and can be completed? This is explored in the subject of finite element analysis. ECS West can be broken down into an example through a table. Now, a table needs to be able to hold a load of your food, which is applied as a force. And the force is distributed along the table and into the leg of the table. So the leg of the table is holding part of that force, and the leg can be broken down into different elements as well. So as we keep breaking down these elements, we can come down into a minuscule portion of the leg that can be referred to as a voxel. Now, the voxel is composed of these nodes on the corners of this box. And as we keep breaking down the force, we keep breaking it down until we can break down the forces onto the faces of the voxel. Each of the faces of the voxel is able to have a different composition of the forces on the face. And here is when we are able to apply linear algebra and translate those forces into a matrix. Now this matrix is going to hold the formula of the forces on each face. The matrix is broken down as the formulas between the displacement and the forces applied on that face. All of this can be encompassed into a software that is able to manipulate our knowledge to test designs that we put into the software.
I am using Abaqus as a finite element analysis software. From this example, we have a beam. The beam had an applied load on the right side and also was under the force of gravity, while the left side was in a fixed position. This is an exaggerated view showing the displacement, stress, and strain on the beam itself. And as you can see, the beam is split up into multiple voxels just so we can determine where failure mode would occur. This simple beam example is just scratching the surface of what this software is capable of. As you can see in this next picture, I imported an abdominal aorta, and we can use this software to analyze the failure points, such as when blood pressure is too high and stress around the aorta as well. And that's our project.